here to show us all the details on how you actually make this stuff happen. I'm just going to do a bit of an intro or positioning, if you like, of where we see the cloud and how it's going and how you can get involved in that, and really how it can help you transform the business, I think. Let me start with jumping ahead here on the slides. And that's me. So I look after integration for Microsoft in Australia, and we have within the integration team, if you like, or the extended team, we have what we call virtual technology specialists, and there's two guys from Breeze, Nick and Scott, who help us extend the reach, if you like, of the integration specialist team here at Microsoft. So, I think one of the main things we talk about when we're thinking about the cloud, well, the main business benefits really is that it's going to save us money. So, you know, if we just think about moving our infrastructure and applications and so on to the cloud, that's going to lower the cost of IT. But obviously there's a lot more to it than that, and that's kind of what we're talking about today. So increasing your business flexibility and agility, I think, is one of the key points here, where we can quickly put on new applications into the cloud and in fact change the way that our business does its business. So really sort of transforming the business and the experience for our customers, suppliers, and everyone involved in the business. You've probably seen that over the last couple of years, I guess, we've really been building sort of a symmetry of capabilities, if you like, between Microsoft software, that's the on-site software that we know and love and install every day, and what we're providing in Microsoft Cloud Services. Microsoft's been in the cloud for many years now. If you think back to Hotmail, even Xbox Live, I think, is a great example of, you know, bringing the cloud to the living room, really. But across this stack, you'll see from productivity, communications, business apps, and so on, we're really getting a symmetry of capabilities, both on-premises and in the cloud. Now, today we're really talking mostly about the platform as a service, which is provided by Windows Azure. And that covers database, platform, other things as well, so it does touch on the identity side of things and really a whole gamut of capabilities there. So if we drill into the platform of Windows Azure, we can see that it is already an incredibly rich platform and allows us to really develop pretty much any sort of application that we want. You'll also notice that it's not just .NET, so we're really opening the whole application development community, if you like, to leverage everything that people are doing today out there in the development land. So some of the capabilities are listed here, and you'll see that we're adding more as time goes on. So I guess the question you should be asking first up then is, given that we have this huge capability in the cloud, why don't we just put every application up there? Why don't we, you know, rewrite everything that we're doing and put it in the cloud and reduce the cost of doing IT, increase our business agility, and really transform how we're going to do things? So as I talk to people around the country, there's sort of two things that really pop up as, you know, the excuses, if you like, or the reasons, probably a better way to say it, as to why they don't have everything moved to the cloud already. And the two things are really around regulation. So some of that is legal. So, you know, law saying that we can't move our data out of the state or the country or whatever. What I would do on that, though, is really go and find out what the regulations are around that, because there's a lot of myths around, you know, what you can put offshore, what you can't put offshore. And so if you're contemplating that and you do see that as a blocker, I would behoove you, I like that word, to go and really find out what actual regulations apply to you. There's also just some internal rules, if you like, that prohibit that kind of thing. So your department or your company or your organisation might not like the idea of that. And again, drill down on what are the business reasons that they're asking for that restriction. And also, there's a lot of these regulations are just assumed. You know, we think for some reason we can't do this. And again, drill under the covers and see what the real reasons behind those things are. The other big blocker, I guess, to moving your applications to the cloud are what I would call or list under current investments. And those things are, you know, simple things like hardware, obviously. You know, if you've just paid $1 million for a new computer, you want to get the most out of it, which is perfectly legitimate. Applications, nearly every organisation has literally hundreds of applications running within their data center. And again, although that's a sunk cost, we do want to make use of that investment. But I think the biggest one is the skills, the people skills and the people ways of doing things, I guess, that we've invested in heavily. And those things include things like setting up reliable services, doing security, doing internal business processes that you know how to do every day. And I guess the flip side of that is, a change is always difficult to implement. On the plus side of things, why would we move applications to the cloud? Well, I think it comes back to those other things we talked about: low cost, elasticity, simplicity, those kind of things. So really, I think if we want to get to the cloud, we want to approach it from a low risk perspective. And I think there's a great article that Gartner have just come out with. They did a Platform as a Service 2012 document called Tactical Risks and Strategic Rewards. And really what YASFM is saying there is we need to begin building familiarity with new cloud computing opportunities by adopting some of these services now. Now, there will be some risk there, but what he's really saying is there's greater risk in not going to the cloud. So we need to find a way to kind of dip our toes in the cloud. A bit of a mixed metaphor there, but we want to get a low-risk approach to the cloud. We want to leverage those existing assets that we've already got within the organisation. We want to leverage those processes that we've got behind the firewall and leverage our skills both in developing applications, understanding the business, and all those things that we do every day. So one of the common models I see is not sort of rewriting applications and putting them in the cloud, or even just moving holus bolus an application and putting it in the cloud. The model that I'm seeing adopted really very successfully around the world at the moment is this model that I've put here on the screen. I like to think of this as a detailed architecture diagram, but the point is, I guess, it really shows you what we're about here in this session, in this webcast today. So what we have here in the bottom left corner, if you like, is your existing data center, where you might be running various services connected to databases and so on. If you're using something like BizTalk as the back end there to do your integration of services behind the firewall, what we're saying is BizTalk already has connections to Azure, so you can easily extend the services that you have in BizTalk through an outbound connection to Azure. Once you have those services in Azure, you can enhance them, if you like, with other applications around those services, and then provide additional functionality to your partners or your remote workers, highlighted here by those very detailed pictures of your customers and partners and so on. And really, that's the model that we're talking about today. So still keep your existing applications as they are in the data center on premises, working in a secure, regulated way, but then extend the reach of your enterprise through Azure in a pretty easy fashion, really, and that can extend the reach of your services, if you like, across Australia, or in fact using the reach of Azure across the world if you really need to do that. So the guys from Breeze are going to drill down on exactly how you do this stuff, and also they've got some customers that are really doing this today and made some big impacts in the way those businesses run their organisations. So with that, I will hand over to Mick.
Beautiful. Thanks, Jeff. Okay, so thanks very much, folks, for making your time available. Can you still hear me? Great. Oh, I've got an echo, sorry. Okay, making your time available. So just a quick tip as well. Just on the live meeting screen, if you want to go to full screen, just hit F5 and F5 to come back again. So just might make it a little bit easier for you to navigate the slides and so forth. So I really want to talk to you about integration, so how the cloud can help you integrate. I'm Mick, and we've got Scott with us as well. They're our email addresses, and we're both part of the Virtual Technology Specialist program. out of Microsoft. So we do a lot of work in this space, and we do a lot of integration on both Microsoft technologies and non-Microsoft technologies. So real-world scenarios, and just want to show you just exactly, how some of the things are today and how they can help you. So basically, one of the statements, the cloud, and 640K should be enough for anybody. So that was in 1981. And I think if we all look at our phones these days, it's a lot, the phones pack, I think, about 12 Commodore 64s in them from what I had when I was a wee lad. So basically, who's heard of it? Who's gotten involved? And what I'd like you to do, I've just got a little poll here for a moment. Who's actively using the cloud? So I'll give you a couple of moments to just jump on in and click a button. Beautiful. And so one of the interesting things about this, I'll give you a moment to keep going there, folks, is the cloud doesn't necessarily have to be application-based, okay? It can actually, you can offload some of your infrastructure there as well. And that's quite an interesting scenario when we come to think of it. And what sort of infrastructure pieces would you offload and how would you do it? So what does the cloud do very well? So there's some of the questions that we want to sort of tackle. Sorry, I'll just recap that. So there's a group of us there. Yes, for our applications. So great. All right. And the other big question is, do we need it? So as Jeff's alluding to as well, is it something that we need to take on board? And would we be disadvantaged if we didn't? So certainly from our experience, hybrid applications and those sorts of things, using the best of both worlds, on-premise, off-premise, and how's the best way to connect those together. So we don't have a lot of slides. In the slide deck, there are quite a few slides in the appendix for you around coding and sample pieces of code and things like that, how to take advantage of some of these scenarios. So what I'd like to do is talk to you a little bit about the infrastructure, and then we'll deal with the integration side and bring up some real-world scenarios for you. So we've got a lot of demos. Scotty will be doing some of his service bus magic and various other demos. And I'll show you some things with SQL Azure and something called Azure Connect. So probably one of the things that I like to do is just have a bit of a bird's eye view of what Azure can give us. And over here we have our clients that live in client land. They could be internal, they could be a department within your organization, they could be external. They could be doing a range of things. And typically, they talk to us, to our servers, whatever they may be, servers, databases, mixture of technologies, socket-based systems, SMS gateways, etc. And that's the way that we've been doing things. So in terms of what the cloud brings, I've just mentioned at a high level some of these very key components, such as the cloud compute components, Azure Storage, Access Control Services, SQL Azure, and Service Bus. So a few different things that we can do that, for example, the on-premise applications could actually talk directly to some of these Azure storage, for example, or even SQL Azure up over here. And we could have a database that has been offloaded, if you like, to the cloud that we're talking to securely and just for us. So maybe, for example, going from a single SQL cluster database style to a highly available database is something that's quite quite a big task for the organisation, whereas here is one ready, provisioned. There's at least 3 copies of the database at any one point in time. It's you effectively talk to a virtual database server in effect, and it's high volume, high throughput. So obviously there's nothing stopping us from our cloud footprint talking directly to that as well. And maybe coming down the track, there may be your clients talking either to Azure storage, taking advantage of blobs and queues and tables and so forth, or talking directly to the database that lives over here. But we don't lose control and we don't lose track of what's in that database, because we can control that from within our on-premise applications and the like as well. So there are some very interesting scenarios that arise out of this sort of topology where we have our WCF endpoints. Maybe that's part of your scenario. Maybe it isn't. Maybe you don't have WCF endpoints. Maybe you've got sockets. Maybe, there's a whole series of, maybe you've got a custom database, a PIC system, and various other things. So as Jeff's mentioned, the cloud isn't necessarily just around Microsoft technologies. We can spin up PHP servers and the like and other things if we need to. So what becomes very exciting is how can we use the best of all these worlds together to leverage a beautiful system and solution? And what are the benefits that we get by offloading a lot of what we do on premise to the cloud? So in a scenario, a lot of the public data in a particular client becomes available, and the public don't consume it. A bit like stock market results, exchange rates, various other things. And some of that public data is very high volume. So do they keep increasing their on-premise footprint and bandwidth and internet connections and so forth to cater for this publicly accessible data, or do they push it up to, for example, Azure storage or SQL Azure, and then have a way to access that from within, from clients directly? So in that particular scenario, it made a lot of good sense to push this public data up into this space, so that we've then offloaded all of the accessibility of that as well, so that the on-premise footprint doesn't get affected. The public can go and access that data as and when they need to, and as often as they need to. And there are a variety of other techniques that we can use from the cloud as well to offset that public access, such as CDN and various other things. But simply, the client still controls the data, and they just update the refreshes of that public data every X number of minutes. So it becomes a very interesting scenario. Even things around WCF services, so or service-based. So you expose out some entry points, and we're probably talking about, EAI, B2B, partner-type systems, and you've got web services that need to stay up. And so how then do you scale those web services? So the part of the problem space is, as developers, we can build these web services very quickly. The challenge becomes, how do we make it robust? How do we lock it down? How do we harden it for production? And a lot of the IT pro guys will be telling you, a list long, a list the length of their arm long on all the different things that we need to do, from various IIS settings to, things above and beyond our code, around the packaging of it, around the deployment of it, around security, around, there is a lot more, for example, to write in having a production web service than just writing code. And that's where, as developers, we've written this thing in 15, 20 minutes, we've exposed it out as a web service, surely, or a WCF service, surely that should be enough. I'm done, right? Works on my machine. Whereas production is a very different scenario. monitoring, how do you know it's up, how do you know it's down, all those other things. And then what is the work involved in spinning up that web service on another, for example, web server on-premise? How do you do that? And how do you load balance across those two WCF services, for example? Do you use DNS round robining? Who adds the entries in? What about the firewall rules? So there's a lot of other aspects around just pushing this thing and saying, hey, I've got a web service, come and call it. Oh, but don't call it on a Thursday between 12 and 2 because I'm actually doing some work. And if I don't have my little desktop application running, then the web service doesn't work. Now, I actually took those from a live customer scenario. We actually did connect to a web service that was taken off the air between 12 and 2 on a Thursday, and if a little desktop application wasn't running, we weren't getting any results back in our production EDI system. So it's a very interesting scenario as to what you're connecting out to. So let's talk just a little bit around the infrastructure side of things. So how do you deploy your applications? Is it easy? Is it hard? How do you know versioning? So there's a whole series of management questions. In particular, things like how do you do upgrades? And if the system must be in place, how do you perform these upgrades without any downtime? Things like high availability and other bits and pieces around how do you monitor usage. So obviously Azure does this very well. Obviously the cloud, the Microsoft Cloud, does these things seamlessly and it slots very nicely into the already existing array of tooling that we have from performance monitor to SCOM to your server managers, your Active Directory, Federation services. So from an infrastructure point of view, it becomes a land that you could utilize above and beyond just an application-focused scenario space. Who has data centers? Who pushes things? Why do you push things out to data centers if you need to? Why do you have DR sites from data centers? So all of these sorts of things, and in particular scale is another very good one that obviously we can take advantage of inside Azure. So that not only can we scale up, we can also scale down when we need to. And how do you isolate it? So how do you make sure that one grumpy server doesn't take down that network segment? So in terms of what Windows Azure gives us, fantastic. We've got all these things in there: high availability, resource routing, and one of the other big things that we find with customers is that if the server isn't in a touchy-feely kind of place on premise, how can we give them the level of comfort to say, well, it almost is? It's actually in a data center, if you want to think of it that way. How do we know if it's up? How do we know if it's running? There's something that needs to be responding every 30 seconds. How do we know that's going? And so the beauty about this space is that the monitoring type tooling slots directly into, for example, SCOM and various other monitors. So we can get performance monitor counters from our Azure footprint. We can find out how our services, servers, databases are going, just like you would with on-premise stuff. We can even have remote desktop windows into these things if we want to, so we can add EP onto them. So in terms of what are some of the features at a high level, these are some of the big blocks: SQL Azure, Windows App Fabric, Access Control, Service Bus. So that's gone through a bit of a name change in recent times. But these are some of the things that they can give you and offer you. And certainly down at our level, what I was really referring to was previously was sort of all of these Windows Azure pieces of compute, storage management, and also Connect. So what would I want to take away from an integration piece? And on the integration, if we're looking at some of these technologies, On-premise, we can start to utilize, something known as Service Bus, which we'll drill into, SQL Azure, Azure Storage, Azure Connect. So that's if we're looking to integrate and we've got an on-premise footprint or our applications. At a grab, these are some of the main technologies that you might want to investigate and have a look at. If we're in the cloud or we want to push things to the cloud, then we could also use Service Bus. We could also use Azure, Storage Connect roles and then various endpoints and things. So we can have a very nice combination of the two as, this is really just a verbalizing slide on the bird's eye picture that we had a little while ago that I showed you just a moment ago. So let's just go and drill in now and cover a few of these topics, such as the roles. So what are our roles? And this is really for completeness. So we have 2 or 3 main roles, but we have a worker role and a web role. We also have a VM role, which basically you upload a Hyper-V 2008 Service Pack 2.1 VM, and you can use that. So there are some interesting things around you spinning up instances of those VMs. So we have something known as a web role and a worker role. In fact, there's no real difference between the two. The web role has a full-blown IIS on it. The worker role doesn't. We can, for example, we used the web role recently to establish an FTP server. So basically, you can do anything you want. You open up the ports and you stipulate what publicly accessible ports you'd like, and away you go. So there's a whole variety of different things that you can do with these roles, and these give us a very nice way as a developer to be able to package up our code and drop this into one of these components that then Azure works out how to run and execute and how to make it highly available, responsive, very quick. So our data center, our nearest data center here from Sydney is Singapore. So we get about a 300 to 600 millisecond round trip time with about 120 to 180 messages a second being processed from on-premise to cloud. So there's some very nice things. If we want to offload some of the processing, then that makes it a very nice, attractive feature, rather than going out and spending X amount in hardware, provisioning up the servers, waiting for those to come in, finding the rack space, etc., etc., etc. And then we can drop that back from 20 to 2 if, for the quiet periods. So as part of Azure Storage, this stuff is cheap as chips. Okay, this is great. So we have tables, we have queues, we have blobs, and we can also drop VHDs into there and expose them out as drives to your roles. So there are some very nice things that you can do, and in typical Microsoft fashion, they make all this play very nicely together, such as, VHDs. You can create a VHD locally, upload it to your storage, your Azure storage, and then basically the roles from that Azure storage could start using that data. And, it becomes quite an interesting and attractive feature if you've got a lot of read-only data, if you've got a lot of, master tables and master data and things like that. RESTful access. So we've got, all the latest and greatest. We've got APIs, we've got URLs that we can get access directly down into, our blob data, for example, and the like. So looking at another major component being the Service Bus, access control, and caching. So this is really sort of focused a little bit around the application side of things. And for example, why might I want to use Service Bus or access control and so on? So if we have a look, then we've got, I've got a series of questions here for you as well. So how do you decouple systems, load decoupling? So in other words, if the consumer and provider, so if the provider becomes really busy and just pumps out a lot of messages, a lot of data. How do we decouple the consumer so that the consumer doesn't get inundated and overloaded and can still process things in their own time? And then we want to be able to do some balancing around, balance out the publishing rate, balance out the consuming rate, things like this. And then we might want to have a level of dynamicness in there, such as fire up on a Thursday and be able to say, well, show me all the very important events, the critical events or messages that are coming through. And some other interesting things around here, such as, well, how do we expose our systems out across firewalls? And is that an easy thing to do? Is it a hard thing to do? So, maybe our system is going off and talking to another system, or maybe, there are a bunch of devices and clients wanting to come and talk to our services. How hard or easy is that to expose? So if we look at the service bus here, and we'll see demos of this in just a moment. So the service bus itself basically is one of those technologies. It does bridge the firewalls. We can tap into the service bus from not only within Azure, but also on-premise. So that by creating what we call service bus endpoints, it tends to be WCF oriented. So it is wrapped around WCF world or services based, which is where everything is going and should be. But in many scenarios, we don't have WCF services. We've got a socket-based application. I need to be able to talk to that from my compute instances, for example. So I'll show you how to do that shortly. But for everything else, let's say within WCF, we have a service bus endpoint. Now, the beauty about our service bus endpoint is that once we create it, the client, that address that Azure exposes doesn't change. So we can wrap that up in a nice friendly DNS name. So to all your clients or your other systems, communicating to, for example, your order processing system is always done through that one particular name endpoint. So where our actual service physically lives can move around. So it takes a lot of that hassle out if you wanted to move services, move data centers, migrate geographic services and so on, move things closer to where the clients are and things like that. So it does become quite a useful piece of technology, the service bus, and Scotty will show you a lot in the demos coming up. The other big part around queues is, so whether we're looking at service bus queues, whether we're looking at storage queues, things like that. In this particular case, we've got a publisher, consumer, and these are our service bus queues. So the service bus also has the notion of queuing, so that if the provider and consumer aren't on at the same time, they're temporarily different, then the service bus will still operate and be active and just queue up the results. So obviously in this scenario, we're not looking at sort of request response type messaging patterns where I click a button and I expect to get a result back on my screen or device. Whereas queue, in this scenario, we've got to send a message through. Yes, the receiving party has accepted it, and they'll process it. So Azure handles all of this queuing and all of this. Well, we're not up. Maybe there's failures. Maybe there's, outages and various other things experienced around this end. So there's some very nice things that we can do in there. And essentially, why do we want some sort of queue in our topology anyway? And we also answer it, further to that, why queues. They're a great piece of technology when we're looking at integration. Okay, so that the beauty about a queue is that we could have the one queue and then we could have several consumers spun up. Let's say these are roles within Azure to handle the load of the queue, and maybe that particular decision to scale out the consumer roles is based on the queue length. So if the queue length is between X and X, spin up 3. If it's between a bit more, spin up more, because we're obviously not getting through the amount of messages at the rate that the publisher publishes. So there's some very interesting scenarios that we can have around that as well. And as I've mentioned, the temporal decoupling there, when you know, one party is basically asleep or wakes up at a certain amount of time. Maybe it's you know, for example, banks do a lot of nightly transaction processing and those sorts of things. So it gives us the flexibility and the freedom that both systems don't have to be on at exactly the same time. And then giving you the, if you like, the be-all and end-all, we can have publishers, whatever they may be. These could be clients as well, scaling out the publishers, scaling out the workers, and having queuing in between that ties them together. So the other side to queues is topics. And topics are essentially a queue with a publish subscribe feature on them. So we still publish a message into a queue, and we stipulate that a topic, we're looking for a particular type of message that has these certain properties to it, and then they're our subscribers. So these guys can join at any time, and they can disappear at any time. So maybe there might be a dashboard that wants to pick up a particular type of message, and the one message can be delivered to several subscribers. So it's worth noting that behind the Service Bus queues is actual SQL Azure. It's implemented in SQL Azure, so there are some very reliable and durable storage sitting underneath these things. So there are some very nice things. And not only can we have filters, we can also have actions. So when the filter is created, we can also say, hey, before you send me the message, can you please modify the time to live value or the expiry on it, or maybe a piece of message data, and make it this. So there are some, you know, some very nice features that we have available to us. So moving on to another piece of technology, how do you secure the edge? So things like, you know, how do you integrate your AD? What about security? You know, what about identities, service identities? Who are they running as? Who are these roles running as? What about tokens and other things? How hard or easy is that to do? And usually this comes about when you want to integrate with several systems. Even, you know, being able to give your customers the ability to log in with Live ID, for example. And so when we want to integrate with several systems, we want to be able to take that security extensibility away from the onus of the developer and the application to implement that, and have that just available in the environment. So within the Azure platform, we've got the access control services, and that's the thing that gives us this. For those of you familiar with single sign-on, this is the next gen single sign-on, okay? And it's cloud-based. So we have our single sign-on in the cloud, if we want to call it that, and we can go in and stipulate various rules. We can stipulate, obviously there's simple username and password formats in here as well, but it's a bit like having your own authorization and security service just living there. So whether it's your on-premise applications, whether it's your cloud footprint, whether it's a way that you want to lock down and secure your clients. So often it involves us creating a whole series of, you know, prior to this technology, whole series of maybe client certificates that we use to authenticate our clients with and generate out that way. Here are a whole series of other options that you can use as well. Okay, and with that, I'll hand over to Scotty, who will share out his desktop and take us through a Service Bus demo or three. Over to you, Scotty.
Great, thanks, Mick. So just a quick volume check. That's all good. And
pushing a 5.
Roger that. So I'll just share out my VM here and wait for that to come up. So what I'd like to do is just walk through some of the Service Bus messaging features that Mick was explaining before. So with Service Bus messaging, we really have two flavors. We have the relay messaging, which is the synchronous whether both a sender and consumer need to be online at the same time, and they're chatting away and relaying the messages between them. The other sort of message is the brokered messages, and that's where we get the queues and the topics. So as Mick said, it gives us the ability to perform some asynchronous message patterns as well, where the sender and the consumer don't necessarily have to be connected at the time the messages are exchanged. And using that brokered messaging model, it opens up a lot of the more traditional on-premise integration scenarios, things like durable messages, order delivery, publish, subscribe, also load balancing and metering out the work between many consumers. But when we start dealing with these service bus messaging properties, we really need to start at the Windows Azure platform and then getting our subscription. So when we create our Windows Azure account using our Windows Live ID, we create a subscription down here in the bottom left, the Azure Service Bus Access Control and Caching. When we create our subscription, we then have to create these namespaces, and the namespaces are effectively this logical container that all our service bus, our queues, our topics, our relay endpoints live under. And that namespace also forms part of that endpoint. And you see here I've got the breeze-dev namespace, and then that forms part of the endpoint there, which all my services will be hosted under. So have a look at that. When we go and create our namespace, we get the containers for our queues and topics, and we'll have a look at those in a minute. But I thought we'd start by looking at relay messaging through Service Bus. The scenario that we want to introduce here is the concept of getting stuff for free out of the Windows Azure platform. So as Mick was saying, as developers we build WCF services, we build these business logic, units of business logic, but we're not really concerned too much about the hosting and the running of those. That's for the infrastructure guys. And wouldn't it be nice if we could deploy them to a platform where we just got a whole bunch of this enterprise level hosting out of the box, and things like network load balancing. How can we quickly do high availability? Traditionally, we'd be down there talking with the infrastructure guys, provisioning multiple services, getting network load balancers involved, publishing public address for these endpoints, and it starts to become more of an effort than actually writing and developing the code to begin with. So we're going to walk through a little scenario where I have this server, and it's a little console app, and this guy is just going to publish a WCF server on the service bus that we saw before my breeze-dev namespace. So I've fired him up for the first time, and you can see there he's now connected, and he's exposing this service endpoint at that address. If we were to go to the management portal, you can see if I just punch that service address here, I've got now a Atom feed of all the services that I have running. And you can see now I have my high availability service published, ready for the public, or you can lock it down using access control service and a few other things. So only the people that you want to connect to it can connect to it. So we've got this service running, it's publicly listed, and away we go. So we can now accept calls from clients down onto our service, and you can see here it's a RESTful service. So I'm just using a web browser, and I'm going away and hitting this endpoint. So every time I refresh this, I make that RESTful call, and you can see client A is connecting to that service. If I spin up another client, so what I'll end up having is a second tab here, and I've got client B now connecting to that service. Okay, switching between the tabs just simulates the two clients calling. If I kill the server, then the service is unavailable, and I get an error saying I can't connect, and it's all bad. So how do we get high availability for this server without involving the infrastructure guys, right? We don't want to go and provision new servers. So if I spin up a new instance of that guy, and he goes and establishes that endpoint, with our relay service bus endpoints, we can actually have up to 25 different listeners on that endpoint. And this is the nice thing about it. So if I've got 2 instances of my application running, I might have 2 application servers in my topology. I can host an instance of these guys on each of those. And now if I was to run my clients again, so he's now talking to this guy, so client B. And what you'll find is, another thing that we'll get for free is, and you'll notice we're getting some traffic over here but not over here. So we're getting load balancing out of the box as well. Right, so we're getting not only high availability, but load balancing straight from the box. So if I was to switch this guy off and just keep calling, you can see my other guy's just taking that traffic, right? So that's some of the benefits that we get just using relay binding in the service bus straight out of the box. We don't have to do any extra coding. We don't have to do any involvement with the infrastructure guys, right? So we've got a high availability. So let's move over now to another type of service bus messaging we've got, and that's the brokered messaging. As I mentioned before, the brokered messaging means we can have the asynchronous messaging patterns where we can involve queues, we can have the client and the server disconnected while this messaging pattern takes place. So to demonstrate that, what I've got is a BizTalk server running down here on my on-premise. And I've got a BizTalk application that basically has 2 ports configured, a receive location and a send port. I haven't written any code for this application at all. What I've done is I've used the WCF adapter model within BizTalk to expose my service bus endpoint. So I haven't had to open up Visual Studio and write any WCF code. I configure my WCF adapter using the bindings from the Windows Azure App Fabric SDK, which is now named the Azure.NET library. So you can see there I've got a messaging binding, and this is the one that we need to use when we're doing brokered messaging. You'll also notice we've got the relay bindings here for the relay bindings. So we're doing brokered messaging, and we're setting up a few credentials and those sorts of things to establish that endpoint. So if I've got him enabled, I'm going to turn my host instance on, which is great. What happened is this guy is going to be listening to a queue now up on Windows Azure Service Bus, and clients can go and send messages to that queue, whether I'm connected or not. Subscribing to that receive location down on the premise, I have a send port, which will basically dump some files into this folder here. So that's our messages coming through the cloud down onto our BizTalk server and then onto the file system. So how do we talk to queues? Well, we can write applications using the .NET libraries. We can use RESTful endpoints, those sorts of things. This is a utility which is a great one that was done by a Microsoft guy, Paolo, and it's called Service Bus Explorer. It's part of our top 10 must-have applications for Windows. And what he's done here is just given us some tooling around developing these services as well. So if you're used to developing WCF services and you quite regularly use the WCF test client app that's in the Windows SDK, think of this as the test client app for Service Bus as well. So I'm going and connecting to my Service Bus namespace, and I'm going to get a response shortly, and it'll enumerate all my endpoints, all my queues, and those sorts of things. So with that BizTalk server receive location on, I'll have a queue, and I can use this Service Bus Explorer to actually test my queue. So instead of me writing a client, I can use this tool to go away and test it. So here's my Service Bus namespace. You can see here's the relay service that we created before, HA service. But here's the queue that I'm exposing from BizTalk, BTS receive location, which is what I called it. So it gives me a few stats around how long has it been living, and a few of the what we call the message queue policies. So when we configure the message queue, but I've right-clicked and I've gone test queue. So this gives me a quick way to have a client to go and talk to the queue. So we want to send some messages. Let's send some dummy purchase orders. Almost good. Okay, so here's a message that we're going to send, and now we configure the tool. So we're just going to enable the sender. Let's get some statistics. We'll send WCF, and we'll send 10 messages at a time. That's about all we want here. The receiver, we want to untick that because BizTalk is our receiver. We don't want to test receiving, and we should be good to go. So if we go over to the graph, we hit start, we should see the tool now connecting to our Service Bus queue and sending some messages, and we're getting some pretty pictures. But the client here has gone off into the web, hit that Service Bus endpoint, and put a message on the queue there. And then BizTalk has gone to the queue, picked up the messages, and routed them on-premise off to the subscribing applications. And this demo, it's just the file system. So you can see there's my 10 messages. If we do it again, we can actually see those messages coming through. But the neat thing about this is, what if my on-premise application goes poof? So I'll go to the receive location and I'll disable him. So he's now no longer listening. With the brokered messaging, the client is none the wiser. He's just sending. So there's 10 messages sent successfully. There's another 10 messages sent successfully. So what I have now is 20 messages sitting up in my queue waiting to be picked up. You can see here I've only got my original 20 that's sitting on premise because my on-premise servers had a hiccup. It might be a network issue, it might be whatever you like. So let's start him back up, which basically brings him back online. Now if we go to here, we'll see that BizTalk receive location is going to connect, and bang, has taken the remaining 20 messages off the queue, so now we have a total of 40. So it's that asynchronous, durable messaging scenarios that we can get through the cloud. Okay, so that's relay messaging and brokered messaging. The last thing we just wanted to show with Service Bus is the way that we can build hybrid applications as well using the Service Bus. So we don't necessarily have to have our external partners going through the Service Bus to an on-premise app. We can use Service Bus to talk with applications that we might deploy into the cloud, where we have part of the application sitting in a web role or a worker role and part of our application living on-premise. And we can use Service Bus to have those applications that are in the cloud that we manage talking with our on-premise applications as well. So what I've done is I've created a solution that we've deployed to the cloud, and it's up there. It's called azurachat.cloudapp.net, and basically it's a simple little application that will accept a message that we type into it, and it's going to then talk to our on-premise server that's going to process that message. Now we won't use BizTalk this time because we can use any .NET application that we want to host these Service Bus endpoints, right? It doesn't have to be BizTalk, it can be any .NET app. So we'll give our on-premise server time to fire up, and that guy's going to connect and expose. So there you can see we've got another service bus endpoint, and this time he's called on-premise/echo. We can go to our Atom feed, and we should see, there he is. Here's the on-premise server running, and we can go off and talk to him. So here's my application running in the Azure web role. If I was to go and talk to him, so as a ASP.NET application, it's just using the Service Bus API to make a WCF call through to that service, and we received this echo back from the on-premise, right, which is this guy here, Howdy On-Prem. So you can see Service Bus is not just a technology that we use with B2B or external partners. We can use it in those hybrid scenarios as well when we want to have... Thanks, Tony.
Hey, Tony.
That's great. So we can use this for creating some very compelling hybrid applications and having Service Bus being that messaging infrastructure between the two. Okay, so that wraps up the Service Bus demos. I'll hand us back to Mikko.
Okay, great. Thanks, Scotty. Some fantastic demos there, guys. I hope you sort of caught wind of what was going on with using the Service Bus and the high availability dropping off. The consumers disappeared, and we were still able to fetch messages relatively uncomplicated. There wasn't, the code behind that is not extensive, and we have included some code at the end of the slide deck for you to go off and see. So the thing to appreciate is that all of that was, part of it was in the Azure data center in Singapore, and then part of it was running off Scotty's VM right in front of us here in the room. So it's a very nice scenario that for you guys as developers, as infrastructure guys, could offload a lot of the complicated bits and pieces of the high availability, the load balancing and so forth, and durability to technology such as that. Okay, so what I'd like to do is talk to you about, for the remainder, talk to you about SQL Azure and Azure Connect. So what I want to focus on is the database side of things. And we have a SQL Azure database up in the cloud, and it's a very good database in its own right. We can choose the size. We can do a lot of things when we go and provision it in just a moment. The other piece of very interesting technology is the Azure Data Sync. So we can actually sync up in different ways your on-premise databases to the cloud. So you might have high performance databases running in the cloud, and it's worth noting too that data going into the cloud is not charged. Accessing data within your same geo center is not charged either. So if I've got 10 roles that are all crunching out queries and working with stored procedures and so forth with my SQL Azure databases, then that's not charged either. So it's only when we send data out of the cloud that the charges do get incurred. But certainly it's worth having your calculators. They are very, very competitive prices and so on. So go and check out. Pricing is something we haven't covered here. I haven't touched on, but it's certainly worth being mindful of what is charged and what isn't. So in our case here in Sydney, Australia to Singapore, for example, these fetches aren't just around the corner. So it is sizable to, go off and talk to a database in, Singapore, for example, and then back again. So as a developer, as an architect, I may design my application differently so that I make less frequent, larger type fetches rather than more frequent, smaller fetches, which is what we typically do with our on-premise database servers. Okay, so I will show you a demo of that. I'm just going to share out I'm sharing out my remote desktop window, and I'll just wait for that to come up. It's not there. Let me make a, if I make a change. Okay. Not being shared. Okay, so folks, I'm just going to, it didn't appear that that came up. I'm just going to share out my desktop as opposed to the RDP window. And we're back. All right, let's try that again. So I'm just sharing out my desktop. Not very effectively, it looks like. Something. It's taking a while to kick in, I think. It's unusual. All right. Aha! It heard me. I was about to take Plan B, and I'll just see how responsive it is. And oh, there we go. There's something coming up. Okay, I don't think it's for whatever reason. That's a shame. Okay, so basically what I wanted to show you, I actually wrote a fantastic client to show you some of this technology, and it's known as a console application. And I wanted to basically point away. I've got a local database server, and I won't worry about it, folks. I don't know what the live meeting and so forth thing is doing, so sorry about that. But I'll come back to here for a moment and just have a quick chat. So I have a local database server with a list of my favorite football teams, and I also have an Azure server as well, also with a list of my football teams. And so what we can do is basically have a mix of those two worlds, and I have the one console application where you basically So do you want to get your data from the cloud, or do you want to get it from a local on-premise database? And the only thing different in the client is the connection string. And that's it. Same technology, same code. I can even use the SQL Management Studio to go off and connect to my SQL Azure database. It's quick, it's fast. You know, from the screens in front of us, we don't really get an appreciation of the amount of infrastructure that's underneath these things. And I then had sync set up so that we could actually synchronize between the two worlds, and we have a variety of different ways that we can sync based on, you know, synchronize all the tables and everything in them, or just go through and sync data based on a filter expression, only get some of the rows, only get some of the columns in the table. So there are some very nice technologies that we can use there. And the SQL Sync is something that we employ to do that, and it's a locally running component, and it initiates the synchronization with the synchronization group. So if I do have several databases up there, we can also control how that synchronization path runs as well. So you know, through a particular database near a SQL Azure database server. Yeah, so the interesting thing is about the data is that from a console application or from an app running, you know, on-premise, I can go off and connect to one of those two guys very easily, okay? And I'm connecting to my database server via a SQL connection, so I do need, you know, the appropriate ports open and those sorts of things from within the firewall, because it is a database that I am securely connecting to. Now, the other side of it becomes very, very nice, which is if I've got a role here in the cloud, obviously I can go off and run my little and run the app and connect to SQL Azure in the cloud very easily and very nicely, and it's quick, it's very fast. How then do I, if I want to sort of go back and connect to this database here, which is on premise, how do we do that? How do we do it easily? Is you know, is the question. So I've got it running, you know, in my server room. It's been running for a year and a day, and maybe there's data in here that we don't want to necessarily expose. We've got the secret formula to Coca-Cola, and it lives there, and that's it. So the answer to that is basically the Azure Connect. So if I bring up the Windows Azure Connect, essentially not only our machines that run, so maybe our machines that our servers that run on premise, but also the roles that are, you know, that are exposed up in Azure, they belong to the Azure Connect. And what gets established between them is a VPN over IPsec. And so what happens at that point is that once we have our VPN connection, your firewall rules and things like that still are in effect on both the role and the servers, but we basically we can then have our communications with the role connecting back to the local on-premise servers, and obviously the on-premise servers going off and connecting to the roles as well. So that is WCF independent. So Scotty previously showed us a bit about the service bus and so forth, which was all very much WCF oriented, whereas this is just a straight VPN connection at a lower level, and we stipulate through our Azure Management Console what roles, what machines, both on premise, and what roles belong to each other. And we can even do things such as have, through this technology, we could have a machine in Perth, for example, using Azure Connect to establish a VPN connection with servers in Melbourne or Sydney. So you don't even have to have roles deployed to take advantage of this kind of technology. And so, folks, the crux of my demo at that point was to fire up my console application and use the host name of my machine locally on premise to go off and connect to the database. So the roles know about through the VPN, they know about the host names and they know about the names of the machines and can do DNS resolution and so forth. And it's just beautiful. It's just lovely to watch. So I could do that with, services and various other things, FTP servers, whatever you'd like really that you've got running internally. Patient scanners, RFID pieces. So it doesn't have to be, message-oriented, WCF-oriented either. So this is just, I want to have a VPN connection. And if you think about it from another perspective, we've got a secure VPN connection to some compute power in the cloud that we can turn on and off. We can scale out and back as we need to. So today I'm doing, rendering of Avatar 2, and I've got a lot of graphic work and things like that to get through. So I might establish that in Windows Azure. So I might spin up my 20-odd servers up there, crunch through all the different frames and do the processing required, and then send the results back. Tomorrow I'm through Avatar 2, and I'll be taking on the next movie. So maybe I don't need the 20, maybe I'll scale it back to 1. So it is a very exciting piece of technology. There's many other pieces around that as well, such as Traffic Manager, so we can control our VIPs and load balancing type scenarios and topologies up in there. It's it's great, and it's already provisioned and ready for us to use. So apologies for the demo factor, and I'll record a session and post it up, complementing this slide deck. So I hope you enjoyed it, folks, and ask questions through link or live meeting. So we do have a question coming up. So thank you very much for your time. Thank you, Jeff. Thank you, Scott. Thank you, Gail. Thank you, Linesman. Thank you, Ball Boys. And thank you very much for attending, folks. And Tony, thanks very much for posting something through. That was great as well on the in the demo. See, so you could see it's a publicly exposed address. Okay. So I was just reading over, just keep the questions coming in, guys. I was just reading over, Tony, your question about the, if I was only to receive FX rates, live feed to a database, what is the pricing? And so we actually have had experience with some of these live feeds of various information out there. So the data doesn't go out of the cloud, so you're absolutely right. The things that you might need to keep an eye on are things like acknowledgements, like packet acknowledgements and those sorts of things, the HTTP responses that come back or depends how the feed is being provided to you. So if it's an HTTP feed, if it's a socket-based feed, there still is the acknowledgements or the return packets that say, hey, I've got that piece of data, okay, send through the next one. So they would be the ones that you might be charged for. But certainly it'd be minimal. And obviously, once your data's in Azure, go for your heart's content. There is, if you're looking at something like that, there is the Azure Data Marketplace as well, so that you can establish cubes and various other data sets up in there for consumption. So you might want to look to establish one of those for on sale or use within your own apps. I've also been told the meeting will be made available on the MS Public Events. You should get an email through shortly, the meeting, the slides, and the recording. So thank you very much, guys. and we will wrap it up if there's no more questions. It's good night from him, and it's good night from him. So enjoy your day. It's beautiful, beautiful cloudy Wednesday in Sydney here. So see you later. Thank you.